one of the things that will kind of be a thread throughout the discussion today is really when starting a new project, thinking about designing for connectivity scenarios in your app, or working with an existing line of business application and thinking about how your GIS data fits into that. It's the connectivity scenarios that are a very important part of it and make a difference for architectural decisions and concerns. And putting some thought into this up front when you're starting out on a project can really make a difference for the long-term goals. And of course, there's a few different options we have when we talk about connectivity. We have the connected scenario, where you can guarantee that you're always going to be connected to your back-end services. And if you're not, you could say this is an error and, oh, is it not on? Actually, you know what? My battery's died.
How did you kill your battery already?
No, he got the good one. I was like, I knew I had it on.
Here, I'll be right back with batteries.
There's a box. No, empty. It's the one it's the one that went last.
Yeah, it's mine.
Okay. All right. All right. Hopefully he comes back and gives me a different mic so I don't have to continue to hold this. So, do I start again because of the recording, Auntie? Or do we just continue on? So, designing for connectivity is a very important part of building apps. So, as I said, we have a connected scenario where you can guarantee that your app is always connected to back-end services. And if it's not connected, that's a failure, that's an error in the app, and you can degrade gracefully from that. So, one of the other patterns would be designing for disconnected apps, where you've taken all of your data offline ahead of time, you have it disconnected on your device, not connected to any back-end services, and you have no reliance on any connectivity while you're actually using the app. And then the third one is where it starts to get a little more interesting, and a potentially occasionally connected environment, where you can't guarantee you're fully connected all the time, but you're not disconnected completely, and you may have connectivity that comes in and out. A lot of our use cases do fall into this scenario. Now, there's different trade-offs for how you decide how to handle this. In some cases, you decide to handle it as if you're connected, and you make the design decision that if you're offline, certain things don't work. Or the pattern that we generally recommend is treat it as if you're working disconnected. If you know potentially that you're going to have occasionally connected scenarios, treat it as a disconnected if you really need to guarantee that everything is going to work and look the same. Also, treating it as a disconnected, you can have more guarantees over the life cycle of that data that you're working with. With sync, you can move from known point to known point, and make sure you know kind of things about the age of your data. And that's only something possible by kind of treating it as a disconnected workflow. So what are we covering this afternoon? So we're going to focus really on talking about the maps workflow. Some new things that have been added in over the last year's worth of work in the Runtime APIs. We are not going to really concentrate on the geodatabase sync task and the export tiles task, as these things are all still in the runtime, but we're really starting to move towards thinking about maps as opposed to the individual layers that power those maps. So rather than taking off those individual layers yourself with those tasks in the runtime, more thinking about authoring the map inside of the platform and then leveraging that inside of your app. So, but none of that stuff has gone away. It's all there. And all the other layer types that we're going to not talk about today, potentially things like tile packages and vector tile packages, rasters, the mobile geodatabase itself. All of this stuff is still in the API. It still behaves the exact same way. Some great sessions that were done on this in the past. They're really good. Check them out if you'd like to learn about them. We're also not going to cover some of the newer things that we've added in recently that work offline. Things like the OGC geopackage, shapefile, ENC, and the vector tile export. So these are some new capabilities that have come in the last 2 releases since June of last year in Runtime, but we're not going to cover them in this section. The nice thing is, these do work disconnected, and some of them, like the geopackage and the shapefile, they work like our other feature tables. And if you check out now the recording for the session we did yesterday on editing, we'll discuss that. We discussed that there about how you work with features, and these are two more sources to power that. So what is a map? And that slide. This is the second time we've done this, Auntie, and I feel like we're falling apart already. Remember the font change that we made yesterday? Yeah. So what is a map? The map is really the central component of the ArcGIS information model. It can be authored once, and this authoring is generally done in Pro or online. It can also be done in the runtime, and then shared and consumed with the rest of the platform. It contains base maps, generally a set of read-only data that provides context for your operational layers, which sit on top of that. The operational layers define the data and generally a set of capabilities and functionality that go along with it. Things like the pop-up, and how you interact with that data, how the data looks through its symbology, all of that's contained with the layers inside of the map. And then additionally, it would have metadata about itself and where it came from. Maps generally stored inside of the portal and then can be consumed, as I said, by runtime and shared with other parts. And really one of the reasons why today we'll focus a lot talking about maps, and hence the title of the session, is it really is that foundational piece of ArcGIS. It really allows you to leverage the rest of the platform. So with services and working with layers individually, you are able to work with those things, and you're able to work with your feature layer, but to have that same consistent look and feel and to work with it with another set of data, this is where that map and scene really comes in to bring all of these things together. So rather than doing this all in code, you want to leverage the rest of the platform. So that way you can more easily adjust for changes rather than having to, say, write code to change the symbology of something on your map. You can actually shift that off, and a map author can do that in Pro or in ArcGIS Online. You don't have to redeploy your app. You can just go down and re-download the map again. So it's easier to account for different changes by leveraging the rest of the platform. So we talked a little bit about some of the connectivity options when you're thinking about designing your app. There's a number of different workflows that back up this to help you support these different connectivity options. Of course, we have our connected maps. As I said, usually distributed through ArcGIS Online or your portals, and you work with it in a connected fashion. And we're going to see a demo of that in a minute. Pre-planned map areas. So this is a map author or a back-end process makes choices about what data is going to go offline, the extent that data is going to be in, and other decisions, the scale that you're going to work at, different options with it, and then it's pre-packaged, and it can be scheduled to be pre-packaged in off-peak hours, and then it can be downloaded and consumed by multiple clients. In the on-demand scenario, you're still taking a piece of your map offline, but it's more done runtime app initiated. So in this case, the runtime app would make the request to the backend services to generate data for a certain extent. And either your user needs to define that extent, or you'd need to code that in your app of what the extent is going to go offline. And then finally, the fourth workflow is the fully disconnected workflow. And this is really about authoring mobile map packages inside of ArcGIS Pro and using create runtime content for data like networks and locators in ArcMap and deploying those out to your app. Now these may never be connected to the internet at all, and there's certain scenarios where this is nice and useful, things like in secured environments, and it's also the only workflow right now that currently supports generating locators and networks to use in the runtime. So with that, I'm going to turn it over to Antti to take a look at a demo about working with...
Number 5, please. Yeah, so I'm going to start this from my portal where I created a new web map. And this contains a water network from Naperville, and it's based on the ArcGIS solution for water dataset that we have published. So this is the dataset I'm using in my demos across the session today. And I just want to jump to the web map definition over here, and I just want to highlight the importance of the map as a central configuration for your runtime applications. As Justin was already mentioning, that's actually what powers all the capabilities, or what are the pop-ups, how we define which fields we can edit in offline, how does the symbology look like, and even what layers we have in a map. And if we want to do any changes over here, and next time when I start my runtime application, it actually picks up all those changes because it gets saved as a JSON file in a portal that we just pull down in a runtime and just rehydrate and bring it live in a map. So my application, this is the same thing that you saw in a plenary earlier this week. But we just want to go in a little bit more details on how this application was built and how the code looks like. And on the first demo here, I just have loaded my web map from the portal item. And as you can see, it has the same data. It's interactive, all the normal stuff that we have here. And the code to do that, it's relatively straightforward. So I just pick up the item ID that I had in my portal, and I'm creating a new portal item based on the ID. And I pass in the portal that my map is part of. And I get portal item instance, and then I'm just creating a new map based on this configuration that I downloaded from my portal. And that's basically it. In my demos, I'm using .NET with the model view model approach. And in this case, when I'm just setting my map over here, that gets pushed into my map view and it starts the loading cycle and so forth. So I'm not going to focus on the UI at all today, but I'm just going to show the API parts that are important to keep in mind. All the code is going to be public later on, so if you are interested on these things, make sure that you send an email to me that I can notify when it's available. But that's basically it. Just get the ID from your portal item. You can also do querying against your portal if needed, or you can get configuration files into your runtime to pick these things up. Create a web map from it, portal item, pass that to map, and put that into map view. And that's all it is.
All right. So, yeah, as Antti said, just a quick recap. Create your portal item, and then you're able to just create a map from that. You get that same look and feel working with it connected. So we started with our portal item, and that was related to our map. And as we talked about earlier, our map has a series of layers associated with that. And those layers, in this case, are backed by different data sources. So you have things like your tile layers, which would be backed by a raster tile service. Feature layers, potentially backed by feature services. Or multiple feature services with potentially overrides on feature service items. Vector tile layers can be referenced in a couple of different ways. The service URL, like we would with a raster tile service, or you can also register custom styles as portal items and then reference those to your map. So all of these considerations when you go into authoring your map actually affect how this data is used and what it looks like inside of the rest of of ArcGIS line, or the rest of ArcGIS, including inside of the runtime. If you, say, reference a vector tile service with the service URL, when you take it offline, you'll only get the default style. You won't get the custom style. So if you want to have a custom style, you need to make sure you reference the item. So these are considerations that need to go into building your map to make sure you know how this is going to look when it comes offline. So switching over to actually start talking about working with your maps offline. Earlier on, we recapped that we have a number of different data types that we can work with when you're disconnected. But there's only a smaller subset of those that actually support being taken offline. So you can be able to go to a service and to be able to clip out and download a piece of that data. This includes tiles, either raster or vector tiles that we have. And these include the Esri base maps, which we have enabled for export tiles, or these could be your own services that you create. Of course, our feature service, which powers our features and our tables. These need to be sync-enabled feature services. And feature collections, either stored as a standalone item in Portal or as a part of your web map. You can download those and use them offline as well. So the one common thing about all of this data is it needs to be enabled for offline use. We're not going to go into this today. We had a demo theater, which I believe is recorded and can be watched later. It was a whirlwind tour of how you enable each of those data types for use offline. So things like this feature service needs to have sync enabled. If you're working with it in a hosted environment, it's really nice. There's a checkbox that you can go flip it on and it works. If you're working with ArcGIS Enterprise and with a enterprise geodatabase, there's a little bit more that you need to do. You need to make sure that the layers have global IDs. You need to make sure that they have archiving enabled or versioning enabled. Then those need to be used inside of your map. And when you publish the service, then you can enable the sync capabilities. So a few more things to do. So all of those data has ways to enable it. And it's very important that needs to be done before it can be taken offline. So one of the patterns that we have for taking data offline is the pre-planned workflow. The pre-planned workflow, as I mentioned earlier, is about having a map author or an administrator or some kind of automated process think about how you're dividing up the data into multiple areas. And all of these choices are about how the data is going to go offline are made ahead of time. Then after the areas are created, the scheduling of the creation of them can be done for off-peak hours, is to maximize the capacity of your back-end GIS. When these areas get packaged, we take a snapshot of the map along with creating a number of different data packages to back that and to support it. So all of those things that we saw on the earlier slide, like vector tile packages, raster tile packages, mobile geodatabases, all of those get created and stored as an items that can be downloaded and used in your app. And then we would continue to do that for each of the areas that we want to take offline. So, as I said, we start with an author or an automated system thinking about how these areas get created. And this is done ahead of time. Then, in an automated way, we can generate our pre-planned areas and do the generation of these. And one of the options that we're going to have for actually generating it will be with the Python API. And this is a simple script that I wrote to look at all of the bookmarks inside of my web map and then go through, iterate through all of those and create a map area based off of those bookmarks. Very simple, a few lines of Python code. This could just as easily be driven by another feature class or something else that's going to actually dictate what those areas look like for your business needs. But it'll be very easy to now take a script like this and you could run this on a regular basis. There's a way to keep things up to date. We also have a REST API where all of this has been exposed as well. So if you did want to create your own tools for automating in a different way, you can go back to the REST API and work directly against those. Once packages are created, then they can be downloaded by the mobile clients. And once they're downloaded, they work just like any other map that you get on your device. You can use them, view them, collect data with them, and synchronize if you're collecting and want either to push your changes up or to get your changes from the server.
What limit is there for data going back up to the server?
So the question is, what limit is there for data going back up to the server? What do you mean? So on the feature, so if you're editing feature data, you can.
I added a feature point to a map. This is my location.
Yep.
I use a drone to record going in and out of a location and have that video, and then I attach it to that location point and give a description on what's going on. Right? Once I get back to a location where I can use a sat phone, then I can push it back up.
So there is a limit to the size of attachments that can be on a feature. I can't remember. We can look at it after. We can find it in the documentation. But there is a certain limit to attachment size in ArcGIS Online. from a sync point of view, especially if you're doing it off of a sat phone or something that potentially an unreliable connection, the ability to package that up, reliably transmit it to the server when it's a large piece of data like that is a concern. This is independent of runtime or not. It's just that doing a huge data upload like that is over a sat phone, if that's what it is not, yeah. We don't have a limit built into runtime in terms of the size of the data, but we know as the amount of data and the size of those deltas increase, there's just more things that can go wrong in terms of the transmission back to the server. The nice thing is if that sync fails partway through, of course your edits haven't gone anywhere. They're still on your device. You can try again. You can wait till you get a hard wire back in the office and then push those changes up.
Now in the case of the hardware, no limits, right?
Sorry? Well, I mean, in the case of the hardware, you just have a more reliable connection, so there's less of a concern with connectivity. But it's still there is a limit on attachment size, I believe, in ArcGIS and in Portal. Yeah. So.
But from
2 gig, it is 2 gigs. Okay. Yeah. Thank you.
For any type of data, or just
that's attachment. That's attachments on an individual feature. It's the individual attachment size. So I don't think there's anything stopping you from putting 4 1.5 gig attachments on it, which is, yeah. But
could I get number 5, please?
You can, for sure. So we're going to switch over and we're going to take a look at a demo of the pre-planned workflow with Antti.
Yeah, I'm also covering a little bit about the sync in this one. So here's my UI for this demo, and as you can see on the left side, I have my map where I see different areas that are pre-created and loaded to online. And on the right side, I have a list of sectors, 1, 2, 3, 4, cleverly named, and they have description of what this area is all about. And what I can do here is that I can just click an area, navigate to it, and in this area specifically, if you look on the map is actually coming directly from the live data source. So this is the current state of my central geodatabase. And look on the red bubbles in the middle. So these points are created after my dataset has been created on the backend. So when I'm downloading the pre-created dataset, and when it's coming down, it gets saved to my device, and then my map is going to change to use the offline data. And what you're going to see is that the points are disappearing, because when I created my backend data, it wasn't there. At that point of time, the edits wasn't in my geodatabase. And this is something that we recommend to doing in pre-planned workflows in general. Like, I come to work Monday at 12, like I normally do. So other people were already doing edits on the field, and I want to get the latest changes when I start working. So after I have downloaded my offline map, it's sync enabled. So what I can do is to just use our synchronization framework to pull down the latest changes and applying those changes to my local copy. So it's a combination of getting the pre-planned area that is created beforehand and then being able to communicate with the changes, either the changes that I have done on my side, pushing those back to the service, or just getting the updates that other people are doing. And of course, I have the option of doing both at the same time. But when we are working with the pre-planned approach, the important part there is that it's sync enabled. You can edit the data, and it's powered by the same infrastructure that we use when you are working with individual layers. If you are working with a single feature layer using geodatabase sync task, you can do the sync. But also when you use the on-demand workflow, either or the pre-planned workflow, you can do the same thing, but on the map side. So let's just jump to the code and see how this has been built. So when I navigate to my page, again, I just do exactly the same thing in the beginning. I just create the map from the portal item. And after that, I'm creating a new instance of offline map task, which is new, or it's been released in the last year. And the pre-planned workflow was released last December, I think. So I'm creating a new offline map task, and then I'm just asking that give me all the areas that are associated with this web map. And it's an asynchronous operation, and after that I just get a list of them, and I loop through them and create the UI based on the pre-planned areas. So for example, here I just have an intermediate model class that simplifies the visualization of the area. And then I'm just creating a new graphic for each and every area and putting that to my graphics overlay. So this is how I get querying all the areas to my device, so I know what options I have. And when I want to actually download one of these areas, again, I'm just creating a new offline map task here, and then I'm creating a new download pre-planned job, passing in the area that I have selected in a UI and defining where I want to store this area. And hooking into the progress changed event, so we get nice user experience. Yes, we are doing work, we are downloading stuff. And after that, I start my job and wait until the download is completed. And after that, after the results has been returned, I just check if there were any errors on the download operation. And the last part here is that I just replace my map in my map view with the offline version of it. And that's all it is. And after you have downloaded the map offline, it's just a map. So you work with the map exactly as you were working with if you created the map in code or if you created some other means. It's just a map. Internally, we use mobile map package format to store these things offline. And when you want to load the map from your device later on, you can just use the mobile map package class to access it. One thing to mention here is that at the moment we have a limit of 16 offline areas per web map. So at the moment we have a limitation there, but we are really keen of hearing that what is the number that you need for the offline areas. So is it enough to have 16 areas, or do we need to raise the limit on the portal side? Back to you. Okay.
All right.
No.
You have high capacity on the portal for storage. Can you set the limit to infinite?
Currently, so the question was about that limit, and can you up it? Actually, currently the limit is not user configurable. It's not it's currently, this is supported in ArcGIS Online only, and it's a limit that we've set and not able to change it per organization. So this is why we're interested in getting feedback. When you have your own portal, that will be something that I would expect to be configurable by yeah.
So just configurable within the portal user control.
Yeah, we would have to double check on that. I assume that's what they're doing, but I haven't seen the implementation of that one. But it would make sense because you're making decisions about your back-end services and what you want to be able to support as opposed to ArcGIS Online and how we need to scale that.
Yeah, policy versus capacity.
So quick recap. It's actually not that many lines of code. Again, it's really simple. If anybody's had to do this in the past, you'll notice how little this is compared to what you needed to write before. So you knew up that offline map task with the map that you're going to use. Then we went and we asked for the list of pre-planned areas or the list of map areas related to our map. When we wanted to download it, we used the download pre-planned offline map and passing it the map area to create our job, and then executing that job does the download.
Can you pass second to number 5? I just want to show one part of the code as well. So I was mentioning about the synchronization as well. So we also introduced new offline map sync task, which is designed to be kind of working together with the offline map task. So what it does is that we go through all the layers and all the tables that we have in a map and consolidate the calls to the geodatabases through one single task. So beforehand, you have to do all of that again by yourself. And so we wanted to simplify the synchronization as well, not only kind of getting the data offline, but also the experience of synchronizing your data between the services. And this is the code that I was using in my my demo as well. So when I click the synchronization button, I just pass in a string that defines the operation that I want to do. And what we can do is that we can either download the changes, we can push our changes, or do bi-directional sync.
I may be getting ahead of you on this, but I know Sync Framework allows you
So at the moment, the offline map sync task only works with the features. So it's not synchronizing the map itself, because when we download the map offline, we think that as a self-contained unit at that point. But we are trying to find some use cases where if we need to extend the capability of doing the synchronization. So I would be curious to hear later on what would be good to get in and so forth. So basically, you can think that the offline map sync task at the moment is geodatabase sync task in steroids. Instead of just working with one single feature service, it works with all the feature layers and tables inside of your map. It's not updating the map itself, more the content of the map. One more. So, as you can see, the pattern is exactly the same. Create the job, task, define the parameters, hook into the progress chains, execute the job, and when you get results, it's finished. So we follow the same pattern in all of our tasks. Fact.
You sure this time?
Yes.
You sure?
I'll give you 5 minutes.
I don't even want 5 minutes. How about 2.5? It's coming back less than 2.5. How about that?
No, just go for it.
We just looked at the pre-planned workflow. The next workflow we're going to take a look at is on demand. And this slide looks relatively similar to the one that we looked at in the pre-planned scenario, but there's one key difference in the middle of it. We still have an author authoring that map and setting it up, but the main difference here is that that generation of that data is driven by the runtime client. So the runtime client needs to make that request back to the back-end portal or online to actually kick off the generation of that data. Then it needs to wait until that data is generated, and then it gets downloaded. So there's no pre-caching. None of this stuff can be done ahead of time because it's all driven by the runtime application, potentially the end user actually performing some action. But once the map is downloaded, it behaves, looks exactly the same as any other map inside a runtime. And that was even less than 2.5 minutes, and I'll turn it back over. We can see some more code.
Code is always nice. So here I have my on-demand page on my app, and this is exactly the same web map that I have been showing earlier. But instead, this time I have a couple other capabilities in the page. And first, I just want to zoom into the area that I want to work with and I want to take for offline use. Then I can define the scale range, what data I want, or how deeply I want to go in my tile layers. And I can do things like defining if I want the base map or if the attachments are included when I'm generating it. So for example, I would recommend you to think that if you don't need attachments, don't include, because there might be a huge payload coming with the attachments. So if you don't need it, just leave them out. And then I just click generate area, and it starts generating, as Justin was saying, that we generate the data packages per request. So at this point, we send the request on the server, and the server starts doing the work and keep doing the work. And when it's finished, and then we have the capability of downloading the areas. So it's fundamentally following a different way of getting the data offline than the pre-planned. And these two ways are not kind of conflicting ways of getting the data offline. They are more complementing each other, where in the first scenario, someone knows the area where we want to go. So that's the people are planning the work. But not all the work can be planned on advance. So in this case, we are working with the water network. We do the regular maintenance work, so we can plan that work. But in some cases, we get some failures somewhere on the field, and that we need to react fast into that. So that gives the on-demand workflow very, very good use case, where you can just go into that area, define the data that you want to offline, and click download, and that's the area that you are going to get. So when I'm downloading the area here, first thing that I want to do here is I'm just getting the current viewpoint for my map, which is an envelope in this case. I'm creating again offline map task, passing in the map that I want to take offline. After this, I'm creating parameters that I'm passing in. And first I'm calling create default generate offline map parameters. Hopefully that's clear enough what it's doing. Passing in the area of interest. And after that, I'm just defining the scale, ranges, and the other parameters that I want to include. One thing to mention here is that when you are working with the geodatabase sync task, you have a little bit more options what you can do with it, because you are working on the lower level of API. And the offline map task is the abstraction on top of all of that. So we have limited a little bit about the options by making simpler API. But if you want to have more control on how it works, then you can just fall back to use the geodatabase sync task instead. And after that, I'm creating a job by passing in the parameters and defining where I want to download my data. And again, I start my job and wait until it's finished. And when the results are back, check the errors. And the last thing that I do here is I'm just passing the offline map that I have now on my device into my map view. And hopefully at this point in time, I have all my data offline again. So that's it.
All right, so this is the picture that we saw before, talking about all the different layers in your map, and then they're backed by services. And the nice thing about what we just did in both the scenarios, in the on-demand or in the pre-planned workflow, is the map, the metadata about it, and these layers don't change. The only thing that's changed is what's now backing these things. In the process of taking the data offline with the offline map task, it's gone out and replaced those services that were backing it by the data packages that were either pre-created or created on the fly. So now when you have this package on your device, it has the same map, the same set of layers with all their capabilities. It's just now pointing to local data packages that you can continue to use. So working with disconnected maps, our fourth pattern. So as we said earlier, these are read-only mobile map packages that get created inside of ArcGIS Pro. And that's one of the biggest differences, is all the things that we've been talking about so far have all been backed by services. So they are all services back or sync-enabled mobile geodatabases so that you can actually do the editing and do the synchronization. But when you create a mobile map package inside of Pro, you no longer have it backed by services, so it is a read-only. But the nice thing is it allows you to actually consolidate data from a variety of other data sources and create a mobile map package with it. So it doesn't have to come from a feature service, it can come from any number of feature sources inside of Pro, and then it all get poured into your mobile map that you can then deploy out to your devices. This deployment happens by sideloading it, either directly plugging the device in or a USB key, or potentially uploading the mobile map package to ArcGIS Online or your own web server, and then downloading that inside of your app for use. One good example of where we actually leverage mobile map packages is with the Esri Street Map Premium for ArcGIS data product that we have. And these are nice base maps for around the world that come with locators and navigation routing, network, with them. And you can get them, you can use them in your own apps by leveraging this data product. So they're a great way to actually see a good example of the use of mobile map packages. And these are what we use to power our Navigator application. So, oh, yeah, and I guess one key, this is the only pattern for putting locators and networks into your runtime applications. We don't currently have support on the services-based workflow for clipping out a piece of a locator or clipping out a piece of a network. You need to process those through ArcMap or ArcGIS Pro to get them to work. All right, so let's see if I can make my way through a demo. Auntie thought it would be very fun the other night to create me a mobile map package to use for this demo, and included some of the new capabilities in the mobile map packages that were released in the 2.1 version just after Christmas this year. He added in a raster into his mobile map package, and of course, we just added support for rasters in our last release, and I needed to update our sample application to work with it. So, if I can figure out how to use the simulator, we can see that I have my map, not a particularly pretty base map. Antti, you should have put more effort into your cartography. But what he did add was a nice raster. And it just worked as another layer in the map. It just came to life. But some of the new things that we added in the 2.1 release, which was a couple of weeks ago, is we now have the concept of whether or not a mobile map package can be direct read or not. So some mobile map package, you're able to leave them as a single archive and direct read into them depending on the contents of the data that are there. Others need to be unpackaged before they can be used. So along with that, we've added in a set of API to make this discoverable and to allow you to unpackage them. So in the case of rasters, we need to unpackage our mobile map package before we can use it. So the pattern would be to, when you want to open up a mobile map package, you first check to see if it can be direct read or not. If it cannot be direct read, then you need to unpack it into a folder, and then you can create your mobile map package from that folder. And then after that, the usage pattern is the same. You can load it up, colon load on the map package, and once it's loaded, get the list of maps that are in it. And a mobile map package can actually contain multiple maps. In the case of the one that we had, that was just one, but in the authoring experience inside of ArcGIS Pro, you can have multiple maps that actually share the same backing data layers.
And this is actually exactly the same code that you can do to use with the offline maps that we create using offline map task. So the unpacked version of mobile map package is actually exactly the same thing that we create when we use the offline map task.
So in summary, taking connectivity into the design of your apps is an important step. And we have a number of workflows, our pre-planned and our ad hoc workflows for taking data offline, a fully disconnected ArcGIS desktop workflow for creating read-only data, or of course, using maps in a connected scenario. And all of these really do rely on leveraging the power of ArcGIS and really leveraging the map as that central component of the geoinformation model. And by leveraging that, you can build greater flexibility into your apps and take advantage of the rest of the platform. So with that, we've covered the main piece of what we wanted to do today, but we have a small bonus chapter that we're adding in. And I'm going to turn it back over to Antti, and he's going to take a look at some new work that we've done with vector tiles.
Yes, thank you. So in the last release, we also released the support for exporting vector tiles from the services. And you can think that as the same functionality that you have could do with raster tiles for a while now. But when we are working with vector tiles, it actually provides us some really neat capabilities and possible ways of optimizing your data usage, especially in the mobile devices. So here I have my map, which is using the night mode street map. And I can name my area here. Let's put Helsinki. I like to use Finnish places for some reason. And I can just call export vector tiles. And it goes to the server, starts to package the area, and then I'm just going to download on my device. But also I'm downloading the custom style that is defined as part of this base map. This vector tile. And for this we released a new export vector tiles task, which follows exactly the same pattern that we saw earlier with the offline map task. So I create a new export vector tiles task here, and I pass in a portal item, which is the layer that I'm working with. And this is actually a really important part here, because the layer itself contains the custom style, and which is pointing into the backing service. So it's a combination of the VTPK file, which contains the styles and the default style, and the custom style that is attached with this layer type. So when you are working with Esri base maps, for example, make sure that you work directly with the portal items and not the URL where the service is. Because the portal item knows where to go to find the data, and also you get the leveraging the custom styles. Creating a default parameters, creating a job. But one of the things that we can do here is that we can check that if this item actually has a custom style or not. and we can optimize the download based on that one. In this case, it has. So I just I can pass in the name of the VTPK file, and then I can pass the location where I want my styles to be downloaded as well. And to using these things, I have here another application. I download a couple of different areas and a couple of different styles already. So with this task, you can actually either download only the VTPK file or only the style or both. So you can mix these different approaches to get multiple areas and then optimize your downloads for the styles, for example. And this is one of the big benefits that we have when we are working with vector tiles. We only have one data set, but I can change the visualization by changing the style. And also another neat thing here is that, for example, if I go to Tokyo, and let's zoom a little bit closer, and I change the style to use the local language, you can see that we are actually using Japanese instead of typical way of using the names. So here it's actually in kanji. So how my app did that one? So I just have one folder here. Let's zoom a little bit closer, where you can see two different VTPK files. And then I have three folders that contains the styles. So what I do here is I just loop through this folder, find out the VTPKs, put those into the list, and then I just create a new item resource caches from the styles. And when I select a new one, then I just create a new layer, which is pointing into a VTPK and the style. And of course, what we can do is that if we just want to go away, there we go. So I have also downloaded a little bit more styles. So if I just drop these styles into my folder here and relaunch my application, I have much more styles that I can use. And with this, the styles that I copied in total of 7 styles was like 2 megs. So the power really comes in where you have one data set and then you can change the visualization by using styles. And this is definitely something that you can leverage in your application to start optimizing the look and feel on the base map information.
Yay.
We have 1 minute left.
We have 1 minute. All right. So with that, let's take some questions. Yes?
Okay, this is a question on the, say I have one feature service that I leverage between different web maps, and I restyle the service for those different web maps. Will that style be reflected when the map is taken offline?
I can take that one. So
make sure you repeat the question.
So the question was that if we have one feature service that is used in multiple web maps, and when we take the web maps offline, does the changes on the service level being used in the offline maps?
Well, say on the web map, I use a different renderer.
Yep. Yeah, so yes, it gets pulled down. So what we do when we create the offline map, we actually load exactly the same representations that we have with the online version of it. And then we take that offline. So all the overrides that you have done along the data chain, so instead of taking the feature service renderer, you can have a feature layer in the middle where you can override the symbols. And if you don't like those things, you can then again override those in the web map. So we take the last version of the symbology. So depends how you build your web map. You can leverage the whole power of changing these symbols. So if you don't override on the web map level, then we take the next one. If there's anything there, then we go to the service level. There was a question over here.
Up here. Oh, sure. Jeff, go ahead.
Yes. Would it be possible to take a map offline, where you showed, and then publish that map back so that other people can take it offline? So I use the ad hoc workflow to take a map offline, and now I want to share it with other people.
So currently we wouldn't support, you can, if you have a map inside of your runtime application, we support saving maps back to the portal or to online, but there was a restriction on the type of data that you're able to do that with. So local data sources don't get pushed back and don't have services spun up to back those. So currently, no, you wouldn't be able to take a piece of data offline along with a map and then take all of that and spin up a new set of services and republish. That's not something, we don't have the publishing piece of the data supported at this time. But Runtime does allow you to create and save maps back to online and portal, but they need to match the capabilities that ArcGIS Online supports, so they need to be services backed.
So two things. One, I want to be able to find this online, all the stuff you just did, so let us know about that. Two, the data itself. You said read-only capacity?
So the question is one about where the resource is going to be after the fact, and the second one is about read-only / what about the data. So all the slides and stuff along with the recordings will come as part of the proceedings from the Dev Summit, and Antti will be publishing his app in, we have a demos repo as part of our .NET samples, as part of our .NET SDK. So that will go onto GitHub in the coming weeks to put all that source code up there. The changes that I saw showed in the sample application for Swift will be thrown away, and they'll be written by a real developer, and that will be updated and will be available on GitHub as well, which is where the source code for the sample app is right now. The second question is the data read-only? The data is as long as the data is backed by sync-enabled feature services, so it's a sync-enabled mobile geodatabase, it's read-write. The case where it's read-only is when it's from the desktop workflow where it's not backed by a feature service. And that's the one where it becomes read-only. But as long as you're working with sync-enabled feature services, it's read-write data.
Just as comment on that. If you want to be notified when the code is pushed to the GitHub, please send me a mail so that I can respond to that one to say that, okay, now it's available. And yeah.
Yes?
I see you guys, you are using the OneSDK for .NET, you are using the OneSDK for iOS. So why don't we use OneSDK for code, which is generic, right? Cross-platform.
For Qt. So the question is, why are we doing individual APIs or working with individual APIs as opposed to using one of our cross-platform technologies? Because yeah, it's not just Qt actually that we support cross-platform. We support Xamarin cross-platform as well in .NET, and Java works on multiple platforms as well. So we have a number of different options for that. It's really, we'll continue to provide a number of options for it. Are the other ones, could we have done this in Qt? Definitely. All of the stuff that we showed today can be done with any of the runtime APIs. The reason we have multiple is because we know we have developers out there that like to work in a certain environment. We have customers with existing line of business applications where they want to integrate in mapping technology, and that may not be done with Qt. And something like on the Xamarin side of things, we know there's a whole lot of C# developers out there who want to work with a consistent set of tooling in a really nice Visual Studio IDE and work with ours. So we have a number of options to do this. For us, the choice doesn't matter. We have everything backed by our runtime core, which is a body of C++ code that really powers all of our runtimes. So we write this stuff once in C++, wrap it to make it look like it fits for each of these APIs that we're working with, and then release our products around that.
So talking about the cross-platform, like OneSDK for Java, OneSDK for code for Xamarin, right? So is there any performance difference?
Nope. So the question is there a performance difference between them? And no, because as I said, actually all like the rendering all happens in C++. So you're getting the same performance on the device. So if you wrote an Android application with our Android SDK, you wrote a Qt application that works on Android, and you wrote a Xamarin application that runs on Android, the drawing of features from a mobile geodatabase onto that on the same device will work at the exact same speed, because it's actually the exact same underlying libraries that are doing all of the rendering. So this is more about what developer tooling that you want to work with, that you're most productive in. So with that, I'm actually going to say thank you very much for sticking out with us for the very bitter end. I hope we keep you at least slightly entertained, and I hope you had a great Dev Summit, and maybe we'll see you guys next year. We'll stick around if anybody's got more questions, but thank you very much for attending.
Thanks a lot.